Hi, welcome to my video about the inhibition and activation of proteins. So proteins play a really key factor in cell signaling or the production of other proteins and that sort of thing. So it's really important to be able to have a steady control on the ability to turn them on, quote unquote, or off. So the type of things that we are going to be going over is competitive inhibition, irreversible inhibition, allosteric inhibition, allosteric activation, and cofactor activation. So the first thing to know is the induced fit model. So essentially what this is saying is that you have a substrate, which the substrate is the actual compound that might be modified or changed and will create the product. And this can be done by things such as an enzyme, which we have over here, which is most commonly a protein. So if the substrate corresponds with this enzyme, then it has to have the exact shape and fit. So essentially what this means is this substrate has to be able to perfectly fit inside, let's say, this train station. So you could think of, such thing as like rainbow flip-flops. So your foot perfectly fits with that flip-flop. This is no different in that the substrate must correspond with the enzyme. And this is really important in making sure that the correct things are being made, or it actually helps in a way to activate and inhibit that enzyme to stop or induce that substrate from changing into whatever product is needed for it to be made. So the first thing that we're going to do is competitive inhibition. So essentially what this is that you have your substrate here, this train, and it is trying to get to the enzyme here to create the product, or the train station. And what happens is that you have another, molecule come up, an inhibitor, and it will block the way of the substrate. So we have this blue and red train here is clearly blocking the path of the substrate. And this is actually an important type of inhibition because it is reversible. So this train here could eventually be released from the active site, which is here in this block on the enzyme, or where the substrate would bind. And that would mean that the substrate would then have the ability to go back to the enzyme and make whatever it needs to make. Now this is different than, say, so here you have an actual diagram showing you have the substrate combining to the active site normally, which is on the enzyme, and here you have another molecule come in and blocks the substrate's way. So what I was going to say is that this is different than, say, irreversible inhibition, which means that you now, as you're going to see, change the shape of the enzyme. So this person here filled in with cement the entryway to the train station or enzyme, so the substrate now cannot get in. So this is important because this kind cannot be reversed. So you can't simply go back and remove this concrete per se and the substrate gets used. So this could be something that's maybe important during like developmental stages because you need something and then something that you don't really need, and signaling, let's say, or a protein that helps you define your arm or your leg, you can stop it from existing because obviously at some point we have to stop growing or stop, signaling for certain things. So that is irreversible inhibition. And the person here is the irreversible inhibitor. So another type is allosteric inhibition, and so this one's different. You can see on a more molecule type image because you have your enzyme, and what happens is the inhibitor comes up in a different part that's not the active site on the enzyme and changes the shape here of the enzyme, and this stops the substrate from being able to bind to the active site. So let's say that, we have this person here and they're going to push this button, or let's say a lever on the enzyme or the train station, and it is going to cause let's say a wall to develop on the enzyme. So the important part of this compared to irreversible inhibition is that this one the inhibitor is acting at a different point instead of just the active site. And the person again is the allosteric inhibitor. So now we're going to move on to activation. So allosteric activation is very similar in that it will bind the what we call a positive effector, you can see here in the molecule image, will bind to a different part of the enzyme, change its shape, will then allow it to bind with the substrate. The substrate now has the ability to connect with that enzyme. So let's say reverse of what we just went over, and we have a person here who is the allosteric activation, will push the red button or lever, and that wall will then be removed. And now our substrate, the train, can get to the enzyme or the train station. Another form of activation is cofactor activation. And what this is that you need another, thing, or let's say cofactor, like this hammer here, will come in and will allow the substrate to connect to the enzyme. So this hammer is going to just knock down this wall, and that's going to allow the substrate to get in. So I hope that you enjoyed my video about inhibition and activation with proteins, particularly with enzymes, and thank you for watching.